Alright, this is lesson 2.3 of variables and patterns. We're going to learn how to read the story of a graph. So we're telling the story a little bit more. We're going to analyze some situations and accurately pair them with their graphs. So it's a little matching game we have here. Alright, let's get started. So for each story we're going to decide which variable is the independent and the dependent, and then pick the graph which best represents it. Graphs may be used more than once, and so we're going to do three things per story. So let's take a look at our graphs. Graph 1, Graph 2, Graph 3, Graph 4, Graph 5, Graph 6. All very different. So let's take a look. A. The number of students, notice it's in italics, that must be important, who go on a school trip is related to the price of the trip for each student. So, it's related to the price of the trip. Let's think about this. If your class is going to go on a field trip and it costs a lot, that's going to make less people go. If it costs a little bit, everyone's going to go. Therefore, the price changes the students. Very similar to the problem we had recently talking about the day at the spa. The higher the price, the less people would go. If you remember right, that graph started out high and then went low. So the graph that seems to match that to me is number 2. Okay, pretty simple. B. When a skateboard rider goes down one side of a half-pipe ramp and up the other side, her speed changes as time passes. So speed and time. Time is always independent. So that must mean speed is the dependent variable. Now, let's think about this. Yes, the half pipe looks like this, with a little skateboarder on here. However, graph 5 is not the correct graph. That's what it looks like, but that's not what the graph of the speed looks like. When this rider is at the top, her speed, if we think about a graph, is actually going to be at 0. She's not moving yet. As she goes down, she starts going faster and faster. So speed's going to go higher and higher. As she goes up the other side, she's going to slow down until she comes to a stop again. So the graph that looks like this, to me, is graph 6. Let's move on. This one's going pretty quickly. C. The water level changes over time when someone fills a tub, takes a bath, and empties the tub. Time is always independent. The dependent variable is the other one. And now we got to pick our graph. Now let's think about this and let's see if we can create our own graph before trying to match it. Before the tub is filled, the water is empty. When we fill the tub, it goes higher until the tub is filled. And then it stops because the tub is filled. Now, when you get into a tub, it rises. You should know this. I'm sure you've taken a bath. So we got in. We take our bath. We get out. Then we empty the tub. Well, there's one graph that looks like that, graph number 1. The waiting time for a popular ride at an amusement park is related to the number of people in the park. Now, here's where it's tricky. Time is in the variable name. However, it's not just time, it's waiting time. In this case, the more people in the park, the longer you have to wait. So the more people in the park, the longer you have to wait. If we think about a graph, if there's no one in the park, you don't have to wait at all. People come, longer wait, people come, longer wait. It's going to go like that. That would be graph number 4. Let's move on. E. The number of hours of daylight changes over time as the seasons change. Well, we have time by itself. So time is the independent variable, which means the hours of daylight is the dependent variable. Now we need to match it with the graph. Now, let's think about a graph. there is never 0 hours of daylight, which gets rid of graph 1, graph 2, graph 4, and graph 6. Now, I guess graph 5 might be okay. However, that's saying there can be a lot of hours of daylight and maybe like an hour of daylight. There is never just an hour of daylight. So graph 3 is right. And if we think about that, it makes sense. So let's think about that. In summer, we have the most hours of daylight. Towards winter, it goes down. Towards summer, it goes back up. Winter, it goes down. Summer goes back up. Winter goes down. Summer goes back up, and it goes on forever. Graph 3 matches that. Alright, F. Weekly attendance at a popular movie changes as time passes from the date the movie first appears in theater. Time is on its own, it's an independent variable, which means attendance is the dependent variable. Now, I'm sure you've gone to a theater on opening night of a popular movie and it's crowded. So the very first day a movie comes out, that theater is packed. It's hard to find a seat. A week later, not as many people. Even later, still not as many. Keeps on going down and down until months later, well, it's not even in theaters, so no one's there to see it. The graph that matches this is graph number 2. Part G. The number of customers at an amusement park with water slides is related to the predicted high temperature for the day. Well, people don't change the temperature changes how many people want to come. So temperature is the independent variable. And customers is the dependent variable. And let's think about a graph. So if we think about a graph, if the temperature is really cold, no one wants to come. As the temperature gets higher, more people are going to come. 100 degrees, it's nice to be at a water park. 150 degrees, not so much. People are probably going to stay indoors. As the temperature gets really, really high, I know it's not going to be 150 degrees, 200 degrees, but if it was, no one would be there. I don't think anyone would be outside at that point. So graph number 6 is the one that matches. Alright, let's check back through the worksheet, make sure we haven't left anything blank. So we were going to read the story of a graph. We're going to analyze situations. Each situation we have to determine the independent, dependent, and pick the graph. We did that for A, for B, for C, for D, for E, for F, and for G. This is the end of lesson 2.3. Up next is lesson 3.1 in variables and patterns.